So we're going to continue with the solution to the practice SAC for SAC2, and we're going to start with question 1 of the short answer. All right, let's keep this short. So you are required to draw the valence structure for each of the following. I just want to remind everyone that valence structure means you're going to show bonding pair of electrons when using the dash. I swear this happens every time. I don't know why. Okay, I'm going to go down in a second. I don't really think using Word is the best idea. We back? Okay, we're back. So the bonding pair of electrons will be shown using the dash, and the lone pairs using the dots. So you need to show both lone pair and bonding pairs of electrons for the valence structure. And for the last part, you also need to identify the elements before you draw them. So we're going to start with part A. So you have H, C, and N. Now, before you start drawing, if you're not sure, it is a very good idea to think about how many covalent bonds these elements want to form in order to have a full shell of it. And obviously, the octet rule is a very limited view, but it is a very good tool as far as year 11 chemistry is concerned. And what it says that the atoms or the elements will want to share electrons to achieve a full shell of 8 electrons. Now, obviously, when I say shell, I mean the valence shell or the outer shell. Now, the only exception here is with hydrogen. But I'm just gonna go ahead and do some of the thinking on the side. So hydrogen has 1 electron, so 1 valent electron, which means that hydrogen actually will want to form 1 covalent bond. So it will want to share 1 pair of electrons in order to achieve the configuration of helium, which is actually a noble gas. And it only has 2 electrons, yes, but it is still a lot more stable being a noble gas. So hydrogen wants to form 1 covalent bond. Carbon has 6 electrons, so it has 4 valence electrons, which means that it needs another 4. And that also translates to the fact that carbon is going to want to form 4 covalent bonds. Nitrogen has 7 electrons, and obviously you can get this information just by looking at the periodic table. If it has 7 electrons, if you use electron configuration, then it has 5 electrons in the outer shell. So it's going to want to form 3 covalent bonds to get 3 more electrons, and it will have a lone pairs of electrons, 1 lone pair of electrons remained. So if you look at that, then you can guess the configuration of HCN, which is hydrogen cyanide. Now, in order for every atom to have the right amount of covalent bonds, so that's the main goal, you want all of these atoms to be able to form all of these covalent bonds that they want to. The carbon's going to need to form a triple bond with the nitrogen, and it's going to form a single bond with the hydrogen. Okay, this is with the shape. The shape has to be linear, mainly because you want the pair of electrons on the central atom, in this case carbon, to be as far apart from each other as possible. These 3 pairs of electrons need to be together because it is a triple bond, and obviously this pair is going to be in the opposite direction. So the shape for this is linear. That's part A. Moving on to part B, I'm going to do the same thing. I'm going to start by thinking about how many covalent bonds will oxygen and fluorine want to form. So oxygen has 8 electrons. Yes, it does have 8 electrons. which means that it has 6 electrons in the outer shell, so it's going to want to form 2 bonds to get a full shell, and it will also have 2 lone pairs of electrons. Fluorine has 9 electrons, which is, so I'm just going to write the configuration here, which means that it has 7 electrons in the outer shell, so it's going to want to form one bond to get 1 more electron, and it will have 3 lone pairs of electrons. So in order to make both oxygen and fluorine happy, and you can use the subscript here as a hint, you need 1 bond here, and you need another one here. Now sorry, that's supposed to be fluorine. You don't need to show the correct shape when you draw valence structure. It's not required. I would encourage everyone to get used to drawing the correct shape, however, but you don't have to. But the question does ask for it, so just think about this. Oxygen is the central atom, and according to VSEPR, it needs to arrange these pairs of electrons around it in a way that the pairs of electrons are as far apart as possible. So if we think about the electron configuration, the electron configuration will be tetrahedral, so it needs to have 2 lone pairs of electrons and 2 bonding pairs of electrons, which are bonded to fluorine atoms. And if we think about the molecular shape, now when the question mentions shape, then it is implied that it is molecular shape and not electron geometry. The shape will be V-shape or bend, because you don't need to take into account the lone pairs of electrons when you write the molecular shape. So that's part B. Let's move on to part C. CH4. Okay, I'm going to start from scratch again, but hopefully by this point, you should be able to draw this very, very easily. So once again, it has 6 electrons, which means that it has 4 valence electrons, and it wants to form 4 covalent bonds. There will be no lone pairs of electrons around carbon. Hydrogen only has 1 electron, and it wants to gain another one, so it wants to form 1 covalent bond. So the valence structure for CH4 or methane is fairly easy. You just have that. Okay, now in terms of the shape, if you think of VSEPR, then the carbon will want to arrange these pair of electrons in a way that they are as far apart from each other as possible. And in order to do that, the shape that carbon needs to take with the hydrogen atoms will be tetrahedral. In this particular question, the electron geometry and the molecular geometry will be identical because you don't have any lone pairs of electrons around the central atom. Okay, part D is a little bit more interesting. You need to determine the identity of metal X and Y. Now, the question does tell you that it is in period 2. So we're going to see period 2, and I'm just going to go ahead and make a guess that X is going to want to form 3 covalent bonds, and Y is going to want to form 1 covalent bonds, and that's a reasonable way to get X, Y, 3. Now I'm going to pull up the data book just to get the periodic table. All right, and we're looking at period 2 elements. So period 2, now if you want to have 1 bond, that would be fluorine. So if it wants to form 1 covalent bond, that means that it only needs 1 more electron to get a full shell of 8. And if it needs to form 3, then it needs 3 more electrons. So that would be, if you think about this is 8, that's 7, 6, 5. So that needs 3. So my guess is that X is nitrogen and Y is fluorine. And I'm going to do my valence structure. Now, if you look at the actual structure of nitrogen, then it does have a lone pairs of electrons on top of the 3 bonding pairs. And fluorine definitely has 3 lone pairs of electrons. I'm just going to make some more room. It does have 3 lone pairs of electrons. That's a terrible drawing. On top of the bonding pair. So if I draw the valence structure, you have NF. So it is a tad difficult to make the dots a little bit neat using this pen, but I'm sure you can do a better job than me on paper with your pencil. It is a very good idea to use pencil for this task, because if you make a mistake and you have to rub it out, cross it out, it can look very, very messy. As of now, you don't need to use pen for your assessment. All right, I'm gonna redraw this as well because I don't like how the F and the dot looks, so I'm gonna try to make it a little bit closer together. All right, now in terms of shape, once again, I'm going to start by considering VSEPR, and nitrogen in this case is the central atom, so it needs to arrange the lone and the bonding pairs of electrons in a way that they are as far apart from each other as possible. If you consider the electron geometry, that would be tetrahedral. But if I ignore the lone pairs on top, then what it actually looks like is you have a nitrogen atom, and then you kind of have almost a pyramid base with the 3 fluorine as the base of the pyramid, and this is a triangle, so the shape is trigonal pyramidal. Now I just want to emphasize, well, first of all, I can't spell. Okay, you don't really need all these excess working out. It's sufficient to just draw the shape and identify the draw the valence structure and identify the shape. I'm not entirely sure whether I'm going to be successful in drawing a box here. That's okay, I guess. So I'm just going to go back and highlight my final answer, and everything else will just be working out that you don't need to have there because the question doesn't specifically ask for it. Alright, I'm gonna let you watch me do this for another 2 seconds, I think. So, okay, and after that we are finished with question 1.